Hello students, welcome to my YouTube channel. In this video lecture, we are going to look at some new questions from Keith Williams' Weight and Balance book. The name of the chapter is Basics. So it includes all the basic questions related to weight and balance, the definitions, simple calculations, formulae, etc. So, new question 101. Taxi mass is the mass of aircraft before startup, immediately after startup, before it starts to taxi, before it starts the takeoff run. Okay, so taxi mass. Now, what is the meaning of the word taxi? Taxi means the movement or the process of the movement of aircraft, the process where your aircraft moves under its own power, engine power, from the ramp position, from the parking position or airport terminal to the runway. Okay, so or after landing, once you have landed on the runway, you exit the runway and start moving that aircraft towards the parking position, right? So any movement of aircraft on the ground surface at airport is called taxi. Okay, so now taxi mass is the mass of aircraft before startup. That means before even you start your engines, immediately after starting your engines, before it starts taxiing, and before it starts the takeoff run. So over here you will have to pay attention to the specific points. Now when your aircraft is parked at the airport terminal building, okay, so when it is parked, the fuel they put the fuel in the fuel tanks, right? They put the cargo in the cargo section, passengers board the aircraft, etc., etc. So all these activities happen simultaneously at the parking area or at the parking place or where the aircraft is parked at the airport terminal building, ramp, etc. So the weight of your aircraft, the weight of your aircraft, weight of your aircraft at the ramp position, okay, when it is parked at ramp or airport terminal, is your ramp weight. This is the beginning. This is the first very weight of your aircraft. That is even before you start your aircraft engines and all that. It is the starting weight of your aircraft at the very beginning. Your aircraft will have ramp weight, and at this point, your aircraft will be the heaviest. Okay, as it progresses, as the as you start your engines, you start moving your aircraft. You go to the runway, you take off, you start flying towards the destination, the weight of your aircraft will progressively decrease because of all the fuel that you will have consumed. Okay, so ramp weight is the maximum weight of your aircraft, is the heaviest weight of your aircraft compared to all other weights. Okay, next, once your aircraft is fully loaded with fuel and cargo, all passengers have boarded aircraft, they will close the doors, right? And then they will start a procedure called pushback procedure. Okay, what is a pushback? It's a process in which your aircraft is moved or pushed away from the terminal building. So there will be some airport terminal building on this side. They will push this aircraft away from that area because wherever that aircraft is located, the airport terminal building, there is this airport structure. There are many other items, ground vehicles moving around, ground personnel like engineers, police, etc. Are all working near the airport terminal building. So once all the activities happen, like filling the fuel tanks with fuel, boarding of passengers, loading of cargo. Okay, so then pushback procedure begins or starts. This pushback procedure, the aircraft will be moved or pushed away from the airport terminal building. And once it moves at sufficient distance away from the terminal building, the pilots of that aircraft will start engines one by one. If it's two engines, so first left engine or right engine, whatever the procedure of that aircraft, so engines will be started, right? So now they will consume some fuel in starting the engines, right? So that is called startup fuel. That is called startup fuel. Fuel needed to start the engines. Okay, that is startup fee. Once you are done starting up the engines and you are ready to begin your movement, that is your taxiing movement, you will call the ATC controller, okay, ATC ground controller, and you will ask him for instructions, ask him for clearance. Now, sometimes at busy airports, there may be delay in your taxiing. The ATC may delay your taxi instructions or taxi clearance. So till you get your taxi clearance, you will be expected to hold position. That means remain wherever you are. During that time, you will continue burning your fuel, correct? Because your engines are working. Okay. Aircraft systems are operating as well, right? So all these operating systems, aircraft engines will consume some fuel during that delay period, right? Once and after that delay period, let's say that delay period ends 10, 15 minutes, 20 minutes, 30 minutes, whatever, and you receive your taxi clearance. So at that point, the weight of your aircraft will be a little different from the weight it was at the beginning, and then at the beginning, at once you start your engines. So the weight of your aircraft at the time of taxiing, at the beginning or the start of taxiing, will be called taxi weight, and it will be a little different, meaning it will be lighter than ramp weight. Okay, correct. So taxi weight is the weight of your aircraft, the start of taxi. Okay, so remember this points. Before startup, the mass of aircraft is ramp mass. Immediately after startup, so it can be taxi mass can also be equal to the aircraft weight immediately after you start your engines. But like I said, there are scenarios where you can expect a delay in taxi clearance, etc. So you have to account for that factor as well in your fuel planning, right? So Bravo is not the accurate option. Charlie, before it starts taxing or at the commencement or at the beginning of taxing is the more appropriate option in this case. So select option Charlie. Delta before it starts the takeoff run. So that is wrong again because the weight of aircraft at the beginning of takeoff run is takeoff mass, right? It's not taxi mass, it's takeoff mass. Now, this takeoff mass will exclude all the taxi fuel. Okay, it will not account for any taxi fuel because once you start taxiing from your ramp position and you go to the runway on this following along this taxiway route, you will be expected to burn all the taxi fuel that you have taken uh, in view of taxiing your aircraft from point A to the runway position. So exclude all that fuel. So your takeoff mass will not include taxi fuel and hence it will not be called taxi mass. Question number 102. Maximum structural taxi mass. Now they are talking about structural taxi mass and its maximum. That means maximum limit, the highest limit, the higher limit, and structural. That means the manufacturer of every aircraft will specify a particular mass called maximum structural taxi mass, beyond which you cannot load your aircraft or beyond which you cannot go. Okay, because if you do cross that maximum limit, the load imposed on the structural limitations or on the structure of your aircraft will be excessive, enormous, and it can be dangerous, okay, with regards to safety, the design of your aircraft. So we have maximum structural taxi mass with the point of view of the structure of aircraft. Again, we also have maximum structural landing mass, right? Maximum structural takeoff mass as well. Okay, so these are the limitations beyond which your aircraft will not be able to support the weight. The aircraft structure will not be able to support the weight imposed on it. Okay, and that structure can fail if you exceed that limit. So manufacturer always specifies structural limitations of your aircraft. There is structural taxi mass when you taxi your aircraft on the ground. There is structural takeoff mass, maximum structural takeoff mass when you are beginning your takeoff run, and there is structural landing mass, right? Uh, the weight of your aircraft when you land at your destination aerodrome. So you have to take care of all these three factors. So maximum structural takeoff mass. So maximum structural taxi mass is specified by the airport operator To prevent damage to taxiways, wrong. Specified by the operator of your aircraft to reduce wear and tear on the landing gear. Is specified by the manufacturer to prevent overloading of the structure. Yes. Specified by the regulator like DGCA, FAA, whatever, to provide an adequate safety margin to prevent structural failure. So again wrong. It's specified by the manufacturer. So Charlie. Takeoff mask includes what? So in my previous video lectures, I have covered this in detail. And if you have watched all those lectures and other payload questions or lectures, you will be familiar with this. I expect you to be familiar with this diagram. So there are different ways. There are three different ways to obtain takeoff mass of your aircraft. So first, you always begin with the basic empty mass, the mass of your aircraft plus standard equipments in that aircraft. So basic empty mass is the mass of your aircraft or the weight of your aircraft when it comes out from the factory. Okay, so it will be the normal weight of your aircraft, structural weight, and standard equipments in your aircraft. Okay, like unusable fuel, reserve fuel which you cannot use at all, unusable fluids, emergency equipment. Now, when you add variable loads to this basic empty mass like crew baggage, food, water, lavatory equipments, etc., you will get dry operating mass, right? Then focus on this part. Dry operating mass plus takeoff fuel or fuel on board. The fuel in the fuel tanks at the start of takeoff run is called operating mass. Dry operating mass plus payload or traffic load is equal to zero fuel mass. Okay, it includes payload, but it does not include any fuel. That's why it's called zero fuel, meaning it does not include any usable fuel. It does include unusable fuel, the reserve fuel, which was in your aircraft from the very beginning. So that will be continued here. But the main component, the main usable fuel, the takeoff fuel will not be available in zero fuel mass, though it will be available in your operating mass. Okay, but in operating mass you won't have payload. So now it's time to add payload because you want fuel, you also want payload. So now at this point you add traffic load or payload to your operating mass, you get takeoff mass. Here you add fuel because you already have payload. Now it's time to add fuel because without it you cannot fly. So zero fuel mass plus takeoff fuel equals to takeoff mass, right? And this is the first way to get takeoff mass. This is the second way. This will be the third way. Dry operating mass plus useful load equals to takeoff mass, which is useful load is a combination of takeoff fuel and payload. Okay, so that is takeoff mass. So takeoff mass includes zero fuel mass plus total fuel load, aircraft and everything in it at the start of the takeoff run, or when you are ready for takeoff on the runway. Zero fuel mass plus traffic load and usable fuel, aircraft and everything in it at the time of liftoff. Now, what is liftoff? Liftoff is the procedure. Let's say this is your runway. This is the beginning of your runway. So you are on the ground. You will start your takeoff run down the runway length, and at some point you will lift off. That means you will leave all the contact with the ground surface, and you will be in the atmosphere, completely in the atmosphere. You will be lifted. You will start generating lift. So this is called liftoff. Okay, that particular phenomenon is called liftoff. So aircraft and everything in it at liftoff, no. Zero fuel mass plus total fuel load, no. Zero fuel mass plus takeoff fuel, usable fuel. Okay, it excludes any fuel. It excludes any fuel like reserve fuel, unusable fuel, taxi fuel, which you will have burned uh, by the time you reach your runway, right? Startup run-up fuel, correct? So all this fuel will be excluded. So this point is wrong. Total fuel is wrong. It's usable fuel or takeoff fuel. You have to be very specific. Aircraft and everything in it at the start of the takeoff run, yes. Zero fuel mass plus traffic load. Now, zero fuel mass is already inclusive of traffic load. It already has traffic load inside. So you need not specify traffic load separately or add traffic load again, right? So this part makes it wrong. Otherwise, zero fuel mass plus usable fuel would have made the right option choice. But since they have put traffic load also, so that is wrong. So Bravo will be the right answer. Performance limited takeoff mass is what? So remember, a few minutes ago we saw there was something called maximum structural taxi mass, and then I told you, in addition to that, we also have maximum structural takeoff mass, maximum structural landing mass. Correct? So there are two takeoff mass limitations. One specified by the manufacturer, and another calculated calculated by the operator of that aircraft. So it can be your pilot, it can be the company you're working for. So manufacturer specifies this, and another is calculated by the operator. Now the one specified by the manufacturer is called maximum structural takeoff mass. The one calculated by the operator or the pilot in command is called performance limited takeoff mass. Next point, this maximum structural takeoff mass is a fixed value. Is a fixed value. Performance limited takeoff mass is a variable value. That means it keeps changing day to day depending on outside atmospheric conditions. It's a variable value. Okay? So now maximum structural takeoff mass. It is the maximum limit up to which you can load your aircraft, or it's the maximum limit up to which your aircraft structure, the structure of your aircraft, can tolerate all the weight inside it. Okay, so takeoff mass. That means that mass of your aircraft at the beginning of takeoff run on the runway. Okay, so there is a limit up to which that aircraft will be able to bear, tolerate, right, the weight inside it. If you exceed that weight limit given by the manufacturer, the loads or the stress imposed on the structure will be excessive, enormous, and that can result in structural failure, structural damage, or structural failure. Okay, so this is your maximum structural takeoff mass value, which is specified keeping in mind the structures or the design materials used in your aircraft. Correct? Now, performance limited takeoff mass. Performance limited takeoff mass is a factor of, or is a takeoff mass which is influenced by outside atmospheric conditions like temperature, right? Pressure, humidity, basically density, altitude, right? In addition to that, the runway length available for takeoff, okay, the obstacles in your takeoff flight path, whether at the end of the runway, once you take off from the runway, there are high obstacles, there are mountains around the airport. So again, in that scenario, you will be expected to have a maximum climb rate, correct? So obstacles around the airport, or mainly obstacles in the takeoff path, that is more important. Obstacles in the takeoff path. Again, this will influence the takeoff weight with which you can take off in the atmosphere. If your aircraft is too heavy, it will climb to a particular altitude very slowly at a slow rate, right? So, and if there are obstacles in your takeoff flight path, that can be a safety issue, especially in INC conditions when outside visibility is very low, correct? So, these conditions that influence your takeoff mass, and these factors which have to be accounted for, which have to be considered before you load your aircraft with fuel, passengers, cargo. Uh, they combine together to form performance limited takeoff mass. So we have maximum structural takeoff mass. We have performance limited takeoff mass, which is calculated by the operator of that aircraft. Next thing, so let's say your maximum structural takeoff mass on a particular day is 20,000 kg, and the takeoff mass that you have calculated, okay, according to your predictions, forecasts, weather reports, the airport environment. Okay, taking into account all this variable, all these important factors, the takeoff mass that you think that you have calculated, which you think is safe to take off with, is 15,000 kg. Okay, so the manufacturer says you can load your aircraft, your takeoff mass of your aircraft up to the limit of 20,000. You have that freedom. Okay, but the calculations that you have performed and the conclusion that you have derived says it's better, it's safer to load your aircraft only up to a limit of 15,000 kg, right? So there are two options in front of you, 20,000 and 15,000. So what will you choose? What option will you select? What will you what option will you go ahead with? Okay, go forward with. So you will, in this scenario, you will select 15,000 kg. Okay, you will select 15,000 kg and not 20,000 kg because it is safer to fly with 15,000 kg. If you fly with this 15,000 kg, you are not only within, okay, within or inside the structural limitations specified by the manufacturer, but also you are safe from the point of view of density, altitude, hot temperature conditions outside, humidity outside, low pressure outside, the airport environment, like obstacles in your takeoff flight path, etc. Okay, so you are safe from all points of view, not only from the structural point of view, but also the real time atmospheric influences outside your aircraft. So you are safe from that point of view as well, right? So in this, you will always take off with a smaller takeoff value. Okay, a smaller value between these two, structural takeoff mass, performance takeoff mass, right? It's the name itself suggests the significance, performance takeoff mass. That means this takeoff mass will influence the performance of your aircraft, its speed, its landing ability, okay, all that. So, and next very important point, this particular takeoff mass with which you have decided to load your aircraft up to the limit will be called regulated takeoff mass. Okay, this particular takeoff mass will be called regulated takeoff mass. Means this is the mass that you expect to take off with. Okay, so this is the difference. This is the meaning. And now let's select the correct option here. Performance limited takeoff mass is always. So pay attention to this word. At least minimum equal to the maximum takeoff mass. So option alpha is wrong. Now this performance limited takeoff mass in this particular example, I have taken a value which is much lesser than 20,000 kg. It can also happen that outside atmospheric conditions are very favorable. Yeah, the density altitude is very low. Okay, it's nearly equal to your airport or below the airport elevation. The airport environment is very safe. There are no mountains around your airport or in your takeoff flight path. Okay, so such conditions can contribute to your success or can be very favorable. So in that scenario, it can happen that the performance limited takeoff mass you have calculated tells you to take off with, let's say, 25,000 kg, 5,000 kg more than the structural limitation. But just because the calculation says so, will you do it? No. Because you have to follow the conditions specified by the manufacturer as well. The manufacturer says the structural limitation, the structural capacity is only up to 20,000 kg. Okay? So you have to follow 20,000 kg. So you have to, or you must select a value which is a lower one, a lower between these two values. Okay? So performance limited takeoff mass can be equal to maximum takeoff mass, meaning structural mass, or it can be less than that. It can be also equal to that. So next, always greater than maximum takeoff mass, wrong. It can be less than maximum takeoff mass in high density altitude conditions. Always less than the maximum takeoff mass, not always, sometimes. Okay, again wrong. Always equal to or greater than the regulated takeoff mass. Right. So, like I said, if performance takeoff mass is less than structural takeoff mass, you will select this particular value and this will become your regulated takeoff mass. So you can say that performance limited takeoff mass can be your regulated takeoff. Regulated takeoff mass is nothing but the value with which you are taking off with. Is the value of the takeoff mass with which you are going to take off. So it can be equal to maximum structural mass or it can be also equal to performance takeoff mass. Depends on the respective values. So performance takeoff mass can be your regulated takeoff mass if it's less than structural takeoff mass, or if performance takeoff mass is more than the structural takeoff mass, right? Then it cannot be your regulated takeoff mass value. Then in that scenario, this structural takeoff mass will be your regulated takeoff mass. The correct answer is option delta. It can be equal to regulated takeoff mass or it can be greater than regulated takeoff mass, meaning it can be greater than maximum structural takeoff mass. Next, maximum takeoff mass, meaning structural takeoff mass, always equal to performance limited takeoff mass, like I said. No, they can be different. So wrong. Always equal to or greater than regulated takeoff mass. So it can be less than regulated takeoff mass, right? So option Bravo is wrong. Always greater than performance takeoff mass, wrong. Always less, always less than performance limited takeoff mass, again wrong. So correct answer is option Bravo actually. So just like this option, your performance takeoff mass can be equal to regulated takeoff mass if its value is less than structural takeoff mass. It will be safe to fly with this particular value. So in that case, it will be a regulated takeoff mass, right? Similarly, if the maximum structural takeoff mass is less than performance limited takeoff mass, then this will become your regulated takeoff mass, right? If it's more than performance takeoff mass, then this will become your regulated takeoff mass, your performance takeoff mass. So correct option, it can be equal to regulated takeoff mass like here. If it's not equal to that, it will be greater than regulated takeoff mass. Like here, regulated takeoff mass was 15,000 and structural takeoff mass was 20. So it is more than 15. So there are only two possibilities, equal to it or greater than it, right? So option Bravo. Regulated takeoff mass. Now, what is regulated takeoff mass? Like I said, regulated takeoff mass is any value with which with which you think you are going to take off with. You find it safe to take off with, right? So that value will be a value which is the lower of maximum takeoff mass or and correction performance takeoff mass. So any value which is lower of them, okay, you are going to select that value and that value will be called your regulated takeoff mass, the choice that you make. So always greater than the performance limited takeoff mass. No, there can be scenarios where your regulated takeoff mass is equal to your performance limited takeoff mass. Always less than maximum takeoff mass. Uh, it can happen that regulated takeoff mass is more than maximum takeoff mass. Okay, it cannot be always less. It can be equal to maximum takeoff mass, but not always less than it. Always at least equal to the performance limited takeoff mass. They are saying always. It can happen that regulated takeoff mass is equal to structural takeoff mass, not performance takeoff mass. Lower of performance limited takeoff mass and maximum structural takeoff mass. So option delta, right? So delta is the right answer. Maximum structural landing mass is what? Now again, just like this, just like the performance limited takeoff mass and maximum structural takeoff mass, we have performance limited landing mass and maximum structural landing mass. Again, so maximum structural landing mass will be determined by the manufacturer of that aircraft. Performance limited landing mass will be calculated by the operator of that aircraft. It's a fixed value with respect to the structure of your aircraft. This value is a variable value. Now it will vary with outside atmospheric conditions, density, temperature, humidity, pressure, all that. Okay, again, obstacles in the climb path of your aircraft. Obstacles in the climb path. Now it's climb path. Now here the mass is landing mass. Now you will say, if you are going to land, then why are you concerned about the obstacles in the takeoff path of line path? Because let's say you go in for landing, you are approaching the airport, you are in the landing phase, and all of a sudden you decide to go around to execute a missed approach. So in that case, when you execute a go around or missed approach, you expect to climb your aircraft, right? So therefore, again, the climb path of your aircraft must be devoid of any dangerous obstacles. So therefore, you have to also pay attention to the obstacles in the takeoff path of your destination aerodrome in the event of go around or missed approach. So that is one thing. Again, the landing distance available at your destination airport. So again, this will influence the performance of your aircraft. So these things make for performance limited landing mass, right? So let's say for this value, maximum structural landing mass value is 10,000 kg, and performance limited landing mass value is 5,000 kg. So what will be your regulated landing mass? Your regulated landing mass will be a value which is the lower of 10,000 and 5,000. So the lower value is 5,000. So this becomes a regulated landing mass. You must make sure that at the time you reach your destination, the landing mass your aircraft is 5,000 or less than 5,000. Okay, but not more than that, because it will be dangerous. Let's say let's take another scenario. The structural landing mass is 10,000, but the performance limited landing mass is 12,000, more than structural landing mass. In that case, the regulated landing mass will be 10,000, because now the structural mass is less than the performance mass. So this becomes your regulated landing mass. So maximum structural landing mass is always equal to performance limited landing mass. No, not always. It can be more than that. It can be less than that. So wrong. Always equal to or greater than regulated landing mass. Yes. Always greater than performance limited. No. Always less than regulated landing mass. No. Now it can be equal to regulated landing mass like this, or it can be more than regulated landing mass, right? In this case, regulated landing mass is 5,000, but structural landing mass is 10,000. So it's more than that. So it can be more than that, or it can be equal to that, but not less less than it. So option Bravo is the right answer. Performance limited landing mass is always equal to the maximum landing mass, that is maximum structural landing mass. No, it can be more than that, it can be less than that. Always less than the regulated landing mass. No, it can be equal to it or more than it. Always equal to or greater than the regulated landing mass. Yes. Always greater than structural landing mass. No, it can be less than that as well. So delta is wrong. Regulated landing mass is always less than the greater of structural landing mass and performance limited landing mass. Yes. Okay, you have to select a value which is lower between them, a lower of them, right? So always equal to the greater of structural landing mass and performance landing mass. Wrong. It has to be less, not great. Always equal to maximum structural landing mass. Always greater than performance landing mass. No. So option alpha. Very simple. Next, last, a balance arm is the distance between. So this is your datum. Over here in this particular picture, this is the datum. Now what is datum? Datum is an imaginary plane, okay, or a place from where all center of gravity calculations are made. Okay. First definition. Second, this datum has to be on the longitudinal axis of aircraft, which is an imaginary axis or line beginning from the nose of your aircraft to the tail. Okay, this imaginary line. So that is your longitudinal axis. Third point, this imaginary datum can be anywhere on this longitudinal axis. In this particular example, it's over here, but there can be cases where this datum is, let's say, outside this aircraft, okay, outside the nose of this aircraft altogether, okay, or outside this aircraft behind the tail section, or it can be anywhere inside the aircraft. The only thing is it has to be on the longitudinal axis. Okay, so third point, it can be anywhere on the longitudinal axis, inside or outside, right? Next, this is about datum. Now arm. What is arm distance? So let's say here is your aircraft. This is the datum. This is your center of gravity. So arm distance is the distance between your datum and the center of gravity position or the weight of that object. Okay. So a balance arm is the distance between a load and the leading edge of mean aerodynamic chord. A load and the centroid within which it is loaded, no. Center of gravity and the datum, yes. Center of gravity and the leading edge of mean aerodynamic chord, no. So Charlie. So this concludes our lecture. I hope you have understood all the 10 questions I have answered in this lecture. In my next video lecture, I will solve the next 10 questions. So don't miss that. I will see you there.